Alright guys, time to get started on lesson 63. Hopefully you have your notes out, you've got a pencil. If you want a calculator, then you can take that out now. You probably don't need it for the kind of calculations we're going to do today, but if you want it, go ahead and take it out. And we are going to talk today about solving systems of equations, of linear equations by elimination. Now you're going to remember that we've already learned how to solve systems of linear equations through graphing. Remember, we graph one line and another line at the point at which they intersect, or the points at which they intersect are the solutions that satisfy both equations. We've learned how to solve systems of equations through substitution, where we rewrite an equation in terms of a single variable and we substitute that whole thing in to the equation for the variable. And today we're going to look at what I think is the easiest way to solve a system of equations, which is by elimination. Okay? Our book tells us that sometimes it's not practical to isolate one of the variables in a system of linear equations in order to solve by substitution. Sometimes that's true, it's not practical, but honestly sometimes it's just easier to use this process of elimination, our alternative method, rather than substitution in solving for a single variable. Okay, so we eliminate one variable so that we're left with only one and not two, and then we can take that solution, put it back into one of our equations, and solve for the other variable. Let me show you what I mean. Now, in order for this to work, we have to have two equations where one of the variables has a coefficient that is opposite of the coefficient of the same variable in the other equation. That way, when we do a simple addition, when we add these equations together, that variable will be eliminated. So, for example, let's take this one. If we add 6x minus 7y equals 11 to 3x plus 7y equals 16, we'll get this. Now remember, we're just adding straight across. So 16 plus 11 is going to be 27. 7y minus 7y is 0. Nothing there, which is awesome, because now all I have left are x's, and I can solve for x. I can solve this equation as long as I have only one variable, which I do right now. So 3x plus 6x is 9x, right? 9x plus 0 equals 27. So 9x equals 27. When I divide 9x by 9 and 27 by 9 to get x by itself, I'll get x equals 3. Sorry, I know that's really small, but hopefully you can see that x equals 3. Now that I know that x equals 3, I can take 3 as a value of x and plug it back into either one of these equations in order to solve for y. So let's just go ahead and take that x value and put it in the top equation. We could have chosen either one, but we're choosing the first one. And I'm going to substitute in now 3. Remember, x equals 3, so I put it in for x. 3 times 3 plus 7y equals 16. I get 9 plus 7y equals 16. Now I'm going to move that 9, okay, which moves it away from this side of the equation and over whatever I do to one side of the equation I have to do to the other. So I end up with 7y equals 16 minus 9 is 7. Divide each side by 7 and I get y equals 1. Now my solution needs to be expressed in the form of a solution set or an ordered pair. So that's going to look like this. X is 3, y is 1. Remember, your x comes first, so my solution is 3, 1. All right, that's the solution. Of course, I could go in and I could put 3 in for x and 1 in for y and see if that checks out. If it checks out in both equations, I know I've got my answer right. Let's go ahead and try it here in the next set of equations. So there's nothing I need to do. I don't need to manipulate these equations in any way in order to eliminate one variable. I think it's easy enough to see which variable we're going to eliminate, because the y, again, is the variable that has opposite coefficients, which means they will cancel each other out when I add these equations together. Now remember, adding these equations together means that I leave all the signs alone. I leave them just as they are. So I've got negative 3 minus 1. Okay, negative 3 minus 1, which gives me negative 4. Negative 4y plus 4y is 0. And then I've got 7x minus 3x, which is simply 4x. Okay, 4x equals negative 4. So this 0 doesn't count for anything, but just so you can see it clearly, I'll rewrite the equation that way. When I divide by 4, I divide this side by 4 and this side by 4, I get x equals negative 1. All right, I'm not done yet. I've got an x value, but I need now a y value. So I'll go ahead and put x back in. I'll use that top equation again. I could have used either one, but I'll go ahead and use the top one. 7 times negative 1 minus 4y equals negative 3. Negative 7 minus 4y equals negative 3. I'm going to add the 7 to this side because I need this to move, right? I need to get it off of this side of the equation and over to this side of the equation. So I'm going to add 7 over here. And I end up with, now be careful, there's a negative sign right here. Okay, so we need to retain it. So I end up with negative 4y equals 4. Okay, because negative 3 plus 7 is 4. Now think for a minute, what should I divide by in order to get y by itself? I don't want to have a solution in terms of negative y, but positive y. So that means I need to divide by negative 4, because negative 4 divided by negative 4 is positive 1. That means I need to divide this side by negative 4, and I end up with y equals negative 1. Now remember, I'm not quite finished, right? Because I need my solution to be expressed in the form of an ordered pair. So negative 1 is the x value, negative 1 is the y value. That looks like this, negative 1, and that's my answer. Now, of course, I can check my work again by putting those values in to either one or better, both of those equations to know whether or not I got the right answer. Okay, simple enough so far. Now, let's look at a situation where you can see that you've got the same coefficient for a single variable in two equations. Now, obviously, if I was going to add this equation to this equation, I would not end up eliminating the x's because negative 2x minus 2x is negative 4x, so that doesn't help me. However, I know that I can multiply either one of these equations by anything I want as long as I multiply every single term in the equation and I keep the proportions the same. So if I see that I've got a coefficient that is the same number, okay, for that variable that I'm looking at, but it's the wrong sign, I can change those signs by multiplying the entire equation, because essentially what I need is I need this 2x to become positive so that when I add them together, they will cancel each other out. So if I multiply this entire equation by negative 1, okay, the whole thing, I will end up with the bottom equation here of 2x plus, remember this negative 1 is going to change this sign here, plus 7y equals, now be careful, I got to multiply this by negative 1 also, every single term in the equation, and I get negative 9. Now, when I line up, when I stack up these equations, I'm not changing the signs on the top equation, and I don't have to, okay? So I just need to keep, remember, when I multiply one of the equations by whatever it is I multiply, I have to multiply every term because I'm trying to keep the values on either side of that equal sign the same, okay? I need to keep their proportions. So I don't need to multiply the top one as long as I've multiplied every single term on the one that I'm trying to manipulate. Now that I've done that, it's clear when I add these together that I'm going to get 0, which is what I wanted. I wanted to eliminate one variable so that I'm left with only a single variable, 2y plus 7y equals 9y, and 18 minus 9 is 9. This 0 essentially just goes away here, right? I've got positive 9y equals 9. I can divide each side by 9, and I end up with y equals 1. All right, fantastic. Now I'm not finished because I need to know what x equals. Remember, I need an ordered pair as a solution. So I'm going to put 1 back in. I'm going to put it back into the top equation just in case I made any errors here. I'm going to put it back in the one I didn't touch. Okay, and I see that negative 2x plus 2 times 1, because that's what I got for y, equals 18. Okay, and so I've got negative 2x plus 2 equals 18. Let's move the 2 so that I get negative 2x. So I'm going to subtract it from here and subtract it from here equals 16. When I divide, I need to make sure I divide by negative 2 so that I get a positive x. So when I divide 16 by negative 2, I get x. I'm going to just write it over here because I'm running out of room. Sorry, guys. Excuse me. Next, x equals negative 8. All right. So I have y equals 1 and x equals negative 8. When I put that in an ordered pair, x goes first and then y, and I end up with the solution to this set of linear equations being negative 8, 1. That's my answer. Okay, now you know how to go back and substitute those values in to one or both of these equations to check your work, to be nice and thorough. But let's go ahead and move on to the next set of equations. So again, here we are just looking and seeing that I've got an 11x and an 11x. Fantastic. If I add those right now, as they are, I'm going to end up with 22x, and what I want is no x's. So I'm going to multiply this entire bottom equation by negative 1 in order to make this a negative 11, all right? So let's do that, and I end up with negative 11x. Negative 1 times positive 4y is negative 4y. I'm not done yet. Remember, the negative 1 also has to be applied to the other side of the equation, so I end up with negative 25. My top equation remains unchanged. And now I can do a combination of these two equations in order to solve for, in this case, y, because this gets eliminated. 11x minus 11x is no x's. That's exactly what I was hoping for. Now I'm going to end up with 2y here. 6y minus 4y is 2y. And 21 minus 25 is going to give me negative 4. I'll divide this side by 2 and this side by 2 to end up with y equals negative 2. Great. Now that I've got the y value, I will put it back in. I'm going to go ahead and put it back in again to that top equation and solve now for x. So I've got 11x plus 6 times negative 2 equals 21. Okay. 11x plus 6 times negative 2 is negative 18 equals 21. In order to move that 18, I'm trying to get that x by itself, I need to add 18, because right now it's negative, so to get it out of here and make it 0 on this side, now I've got to move it over here. Okay, I'll end up with 11x equals 39. Did I get that right? Uh-oh. Something weird happened there where I feel like I was supposed, did I make an error somewhere in here? Negative 18, add that to 21. It's looking to me, let's see guys, I feel like I've made it, oh, goodness sake, here. Okay, so if I see something like this and I go, oh my goodness, is this going to turn out right? You've probably already saw and caught it for me, even though I'm not there in class with you. Here's the place where I made the error. Okay, so I didn't make an error in the process, I made an error in the calculation. So let me fix that real quick. Sorry if you've got to go back and erase. But this is going to be easier. All right. 6 times negative 2 is, goodness sake, not negative 18, it's negative 12. Okay, so I'll add 12 over here, add 12 over here. That gives me a much nicer number, which is what I thought Saxon wanted me to have. So that when I divide 11x by 11 and 33 by 11, I get a nice clean x equals 3. Great. Now, of course, I can check that work when I put this into an ordered pair, which is going to be 3, negative 2, because this is x and this is y. Here's my solution. I could put those in to either one or both of those equations and make sure that I did those calculations correctly. Okay, let's talk now about what happens if I've got a slightly different situation here, where I could approach this, honestly, in multiple ways. And you guys have learned different ways to approach this now. I could graph these lines and figure out where they intersect. I could put one variable in terms of the other, okay, and I could substitute them back in. Or I could recognize here that I have got something going on in these equations whereby, so for instance, okay, if I'm looking at, let's say, my y variable, yeah, let's look at my y variable. Now, I'm going to rewrite this equation to show you what I mean, okay? So, because I've got something kind of strange happening, let me take the first step and then I'll show you the second. 3x minus 6y equals 18. If I were going to try to combine these right now, I would have a little bit of a tricky time because I need to make sure that my like terms are aligned, and right now they're not. So if I were to rewrite this equation right here so that it's in the same form of this one, x, y equals, and then I've got a constant, look at all I need to do is move this negative 2y, right? And I would do that by adding 2y here and adding 2y here, and I'd get 5x plus 2y, right, equals 6. I can rewrite this equation to be in this form, and it's identical. I just moved this term to this side of the equation. Now that I can see that, I've got 3x minus 6y equals 18. Forget about this, I rewrote it. Okay, so pretend like that's not there. Now I've got 5x plus 2y equals 6. If I look at my x's and my y's, I should be able to recognize that if I take this entire equation and I multiply it by 3, I'm going to end up with a 6y. See how that works? Which means those will eliminate. They will cross out. So that's what I'm going to do. Okay, I'm going to multiply one equation, not the top one, leave that one alone. I'm going to multiply the bottom one, the bottom equation, okay, by 3. Distribute the 3 to every single term. That will give me 15x. Now watch this. This is cool, right? So I just distributed this one. Now when I distribute the 3 to the 2y, I get plus 6y. Yay! Look at that. Now those are going to eliminate. But I'm not finished yet. I need to make sure I distribute the 3 also to my 6. So I'm multiplying 3 times 6 and I get 18. Now I can do what I've done on all the equations above. And I can just go ahead and do a straight addition. I can see that these are going to eliminate out. And on this side, I'm going to get 18x equals 36. When I divide this side by 18 and this side by 18, I will get x equals 2. Cool. All right, so I've got my x equals 2. Not done. Remember, a solution to a system of equations needs to include both variables, so I'm going to express it in terms of an ordered pair. So I'm going to take x equals 2, put it back in my top equation, 3, there's my x, so I'm going to put the 2 in there because that's what I just found, x equals 2, minus 6y equals 18. Let's go do the calculations. I'll end up with 6 minus 6y equals 18. When I subtract 6 from this side and I subtract 6 from this side, I get negative 6y equals 12, right? A positive 12 there. I know this is getting small and I'm running out of room, but I'll need to divide this by negative 6 and this by negative 6 so that I end up with y equals, right? So I divide this by negative 6, so I get y. 12 divided by negative 6 is negative 2. Don't forget, I'm just putting boxes around these right now so that I can see them in all of this work. Okay, and I know that I need to express this as an ordered pair. X goes first and then y, so my solution is 2, negative 2. Pretty cool, huh? Okay, now let's see if we can do something similar here. On these two equations, negative 2x plus 5y equals 6 and 6x minus 2y equals 34, I see that if I multiply the top equation by 3, I'll end up with a negative 6x and a positive 6x, which will cancel each other out. That's exactly what I'm hoping for. So that's what I'm going to do. I'm going to take this entire equation and multiply it by 3. Let me do that work down here. So 3, I'm going to distribute now. 3 times negative 2x is negative 6x. 3 times positive 5y is positive 15y. 3 times 6, don't forget your equal sign, is 18. All right, now I can go ahead and transfer this equation here underneath, and then I will simply add them together And I will have been able to eliminate x's. Negative 6x plus 6x is no x's. Fantastic. 15y minus 2y is 13y. And when I add these together, I get 13y equals 52. When I divide by 13, any of you with a calculator who can do that math, 52 divided by 13 should give me a quotient here of y equals 4. All right, not done yet. Go ahead and make sure I keep a hold of that visually. Now over here on this side, I'm going to take that 4 and I'm going to put it instead, you guys, I'm going to use the bottom equation because I messed with this top equation a little bit. So I'm going to put y in the bottom equation just in case I made any errors that I didn't catch, okay? And if I did, they should become apparent now. So if I put 4 in for y here, then I get 6x minus 2 times 4 is 8 equals 34. And I get 6x, I'm going to add 8 to each side. 42, divide by 6, and I get x equals 7. Okay, now my ordered pair, my solution set is going to be first my x value and then my y. So it'll look like this, 7, 4. And of course, I can go back and put those values in for x and y to either or both equation to make sure that my math is right. Okay, let's take it one step further. Okay, so we're going to take one step up from here. And again, this is kind of just a matter of looking at these equations like puzzles and seeing how we can fit the pieces together to end up with the correct solution. So when I've got these two equations, and I'm just sort of trying to analyze my options here, okay? Because I know that I need to get this equation in terms of one variable so that I can solve it. And since our lesson today is going to be solving systems of equations like this through elimination, I want to think through how could I eliminate one of these variables. All right, so I see 2x and 2y, both positive, and I see negative 5y and negative 3y. So I have to think here, how can I transform these equations so that one of those variables will eliminate? That means that I need opposite coefficients. So I could either choose x's or y's, and it looks like you have a typo here, guys. These should not both be y's. Let's make this one an x, okay? I think that's just a typo. Okay, so we can either transform our x's or we can transform our y's. I want to transform my y's because when I'm looking at these, I can see that I could easily transform this to 6y by multiplying the whole thing by 3. And I could easily transform this to negative 6y by multiplying the whole equation by 2. And then those variables would eliminate. Now, I could have the option to multiply this equation by 5 to make this 10x, and multiply this equation by 2 and make it negative 10x. Either way would work, okay? But I'm going to pick the y version right now to make these, transform these both into 6's. So that one will be positive, one will be negative, and they will eliminate, all right? So that means that I'm going to multiply this top equation here by 3. Now, lucky for me, I can multiply it by positive 3 because I've already got a positive 2 here and a negative 3 here. Okay, so I've already got a positive and a negative. So that means I don't need to change any of the signs. So let's go ahead and do the distribution. 3 times 2x is 6x. Plus 3 times 2y is 6y. Don't forget this one, okay? So we distributed here, we distributed here. I need to distribute that 3 over here, this side of the equals as well. 3 times negative 8 is negative 24. Okay. Not done. I need this to end up being a negative 6y. Now remember, I can, as long as I multiply every single term by the same thing, I don't need to multiply them both by the same number. I just need to make sure that I keep this equation proportionally consistent, okay? So I'm going to multiply the whole entire equation here by 2 so that I can turn this into a negative 6y. Watch. 2 times negative 5x is going to give me negative 10x. 2 times negative 3y gives me negative 6y. And 2 times 14 gives me positive 28. Now when I combine these, okay, I get 6x minus 10x, which is negative 4x. 6y, positive 6y, negative 6y, these just eliminated. Awesome, that's what I wanted. Okay, so I'm not going to go through the trouble of writing 0 right here. I'm just going to say those are gone. Negative 4x equals negative 24 plus 28, which is positive 4. Be careful here. I need this to be I need my x to be positive. So in order to make x positive, I need to divide by negative 4 on this side. Whatever you do to one side of the equation, do to the other. Divide by negative 4, and I get x equals negative 1. Sweet. Okay, now I'm going to take this negative 1. I'm going to stick it back in this top equation right here, the way that it was before I manipulated it, okay, to make sure that I did the math right. So 2 times negative 1 plus 2y equals negative 8, negative 2 plus 2y equals negative 8. Add the 2 here to move it from this side to this side, add 2 over here, and I get 2y equals negative 6, because negative 8 plus 2 is negative 6. When I divide 2y by 2 and I divide negative 6 by 2, I'm going to end up with y equals negative 3. This is not the way your answer needs to look, okay, where you've got two separate boxes here. Remember, it needs to look like an ordered pair. So x is negative 1, y is negative 3. That means my solution set for these two equations right here, and let's see, I think you can see over here. Yeah, so let me just go ahead and write it over here. My solution set over here is going to be negative 1, that's the x value, negative 3. Okay, there's my solution. Okay, one more to go. Let's see if you can think through, look at these equations, and tell me which one of these variables do we want to eliminate. Do we want to eliminate the x's or the y's? The y's look easier to me because, again, I can see that I could make this into a 6 and this into a 6, right? If I'm looking at 8 and 5 over here, in order to eliminate one of these x's, remember the coefficient needs to be exactly opposite, and the smallest coefficient that I could make out of these, right, where they have a common coefficient would be 40, and I just don't want to deal with those numbers right now. So I want to change the y's into, the coefficients for the y's into 6's, okay, because those numbers will be smaller and easier to work with. However, does anybody see what the problem is here? Okay, we've got one other thing that's going on here, and that is if I simply multiply this equation by 2 in order to transform this into a form of a 6y, and I multiply this equation by 3 so that my y coefficient becomes a form of 6, they're both still negative. Okay, so and negative 6y minus 6y is going to be minus 12y, and that's not what I want. I'm trying to get rid of one of them. So that means I'm going to need to multiply one of these equations by a negative number in order to change those signs. So I'm going to do that to the top, okay? Multiply the top. Instead of just multiplying it by 2, I'm going to multiply it by negative 2 in order to give me a positive 6y here and a negative 6y here when I multiply that equation by 3. All right? Let's do the distribution. Here we go. Negative 2 times negative 8x is 16x. Negative 2 times negative 3y is positive 6y. Negative 2, don't forget this one, times 26, okay? And if you have a calculator, then you can put it in your calculator. If you can do it in your head, you can see that that's going to be negative 52. Great. Let's multiply the second equation now. Remember, our goal is to eliminate one variable, so it needs to have they need to have opposite coefficients. 3 times negative 5x is negative 15x. Oh, I like those numbers. That's looking like it's going to give me something small. I like that. 3 times negative 2y is negative 6y.